Good morning, and you're very welcome to this webinar. My name is Michael Hennessy, and I'm the head of the Crops Knowledge Transfer in Teagasc. The Teagasc and Boortmalt Malting Barley webinar is the fifth and the last in the series of webinars Teagasc have completed in 2022 so far. This morning we have a fantastic lineup for you, which touches on research and farmer practice, which helps you to achieve your malt and barley specs in 2022. The quality of Irish barley and whisky is well known worldwide, which I suppose is the continuation of the expansion of the drink sector. A recent report predicted that the Irish whisky sales are forecasted to exceed Scottish whisky sales in the US by 2030. However, with the rise in exports comes a rise in demand, which is great for you, the farmer. However, it may also come with more strings attached as competitors try to differentiate themselves further in the marketplace to get competitive advantage. Sustainability is certainly a word that's out there and bandied around quite a lot. It's not just a word, but a concept that resonates extremely well with consumers. So it's going to be around with us for a long time. So maybe it won't just be enough to grow barley within spec in the future, but consideration will also need to be given about how sustainable that crop is. So this morning, we're going to first look at the immediate concerns about growing the crop with an emphasis on nitrogen and cover crops. We will then look at the sustainability of growing malt and barley, and finally look at the activities being completed by Teagasc and Boortmalt as part of the Teagasc Boortmalt Programme. We'll first go to David Walsh, chemist, who is a farmer and brewer in County Laois, to talk about the barley production on his farm, and then to Owen Lyons, a Teagasc Boortmalt Joint Programme advisor, who will talk about cover crops. Don't forget, if you want to ask a question, type it in the Q&A box, which is just down below, and you can see that at the bottom of your screen, and we'll try our best to get through all of the questions. So without further ado, I'm going to hand across to David and Owen.
So I'm here on the farm with David Walsh, chemist, just outside Strabane in County Laois. Now David has been part of the Boortmalt Joint Programme as a monitor farm for the past 3 years. And today I'm just going to ask David a few questions and get some insight into how he manages both his brewing and distilling barley on the farm in relation to his N, P and K applications, and also what his plans for this year are in relation to fertiliser application on his crops, considering the way the fertiliser market is currently.
Yeah, well, malting barley has always been the main crop in terms of a tillage crop that we've grown here. And then for distilling barley, it was really when Waterford came in back in 2016, we grew from them for the very start. So that was really when we, a significant chunk of our malting barley was distilling from then on. Most of the farm is index 2 or index 3 for both P, 15 or 120 for distilling barley. Now that's overall nitrogen. So what we will try to do is we've been growing cover crops here for the last probably 5 years at this stage, seriously, like every year we're putting in cover crops, and we will make a cut in the nitrogen rate that we're applying based on how the cover crops have been. This year we've had actually really good cover crops. We got them sown really early. I think they were in by the 8th of August, and then we had such a mild autumn that they grew really well. So they're the best cover crops we've ever grown. Teagasc have analysed them. They reckon it's about 45 kilos of nitrogen in them. And then it's just a case of how much are we actually going to get back into the soil. So the rate is between 0 and 40%, which isn't necessarily very helpful, but I think what we're probably banking on this year is about 20% of that 45 kilos. So that's what we're going to cut off our applied nitrogen rate, and we're also going to cut the actual nitrogen rate that we're putting on. So we're going to go with 135 kilos for brewing and 110 for distilling. What we're trying to do with P and K is we're definitely not going to try and build P and K this year because of the cost of fertiliser. So the idea for us is to just try and maintain it for this year, and then obviously hope that the fertiliser price is going to go back down again. But I suppose because we're 2 and 3, index 2 and 3, I'm not too worried about trying to build phosphorus and potassium in the soil. I'm happy enough if we can just maintain it at that. We're doing a lot more chopped straw as well here as well, so I'm hoping that over the few years that'll start to build up as well.
So just to quickly recap on some of the main points that David addressed for his farm. For his brewing barley, typically David would apply 140 kilograms of nitrogen a hectare, and for his distilling barley he would apply 120 kilos. Considering the excellent cover crops that are on the farm this year, David will reduce his total nitrogen rate applied to his spring barley by 5 to 10 kilograms a hectare to account for some of the nitrogen that will come from the catch crops. And finally, given the current high fertiliser prices, David aims just to match crop offtake in relation to both P and K application, as this will ensure that his P and K indexes remain the same. So the purpose of this presentation is just to give a quick insight into a catch crop demo that we completed on the monitor farm of John Crowley, who's located in Ferns just outside County Wexford. So the purpose of this demo was firstly to determine the performance of catch crops and natural regeneration. So to complete this, we measured the fresh weight of various catch crops, and from samples taken from the catch crop den, we determined the dry solid percentage and the total nitrogen percentage of the catch crop. And using this information then, we were able to determine the nitrogen uptake of the catch crop, or how much nitrogen that catch crop had taken from the soil and stored within the crop. And by using this figure then, we could give an estimation as to how much nitrogen that catch crop may make available to the following spring malt and barley crop. And as part of the demo then, we also had various treatments. So we had species or different types of catch crop, we had sowing dates and its effect on performance, we had with organic manure and without organic manure, and then also where no catch crop was drilled or where natural regeneration took place. So our first treatment then was a leafy turnip and forage rape mix. And this catch crop was drilled on the 29th of August after the spring malt and barley had been harvested. So there's two treatments then on this sowing date. So we had where organic manure was applied at a rate of 2,000 gallons an acre versus where no organic manure was applied. And just to make the point that this organic manure was applied pre-drilling of the catch crop. So before we applied the organic manure, we also had it tested to determine the nitrogen content of the organic manure. So what we found was that there was 12.5 kilos of nitrogen, or 10 units per 1,000 gallons applied. So these are the pictures which show the two different treatments. And these pictures were taken on the first week of December, and that's also when the sampling took place. So the picture firstly in the foreground is where no organic manure has been applied. And we can see here that there's a fresh weight yield here of 7.6 tonnes a hectare, and there was 25 kilograms of nitrogen a hectare taken up by that catch crop. We compare this then to the picture in the background, and we see there was a fresh weight yield of 12.4 tonnes a hectare and 46 kilograms of nitrogen a hectare taken up by that catch crop. So what we can see here is that there's only slightly less than double the amount of fresh weight yield and kilograms of nitrogen a hectare where the organic manure has been applied versus where it has not been applied. The second treatment then is much the same as the first, but we use mustard instead. So the mustard again was drilled on the 29th of August after the spring barley, and again the two treatments on this sowing date. So where the organic manure was applied versus where no organic manure was applied. So these pictures, again taken that first week of December, show the differences. So the picture in the foreground is where no organic manure applied, and we can see a fresh weight here of 6 tonnes a hectare and 21 kilograms of nitrogen per hectare. Versus the picture in the background where the organic manure was applied, and a fresh weight here of 11.6 tonnes a hectare and 38 kilograms of nitrogen a hectare. So this species, quite similar to the last, we can see that just slightly under double the amount of fresh weight yield and kilograms of nitrogen a hectare where the organic manure was applied. Our third treatment then again was the same mix. It was leafy turnip and forage rape, but this was drilled on the 15th of September after the crop of spring barley. So the purpose of going this late with drilling of the catch crop was to evaluate the performance of a later drilled catch crop, which can often happen with spring barley, especially if harvest run late and clearing straw. And just to note that no organic manure was applied at this stage, as there was a potential for poor uptake of the nitrogen if applied at this stage. So as you can see from the picture taken the same day as the previous pictures, there's a stark difference between the performance of the catch crop. So we can see here that the fresh weight yield is only 2 tonnes a hectare, and there was only 10 kilograms nitrogen a hectare. So, that 2.5, 3 weeks later sowing date compared to the other catch crops is having a major impact on the performance of that catch crop. Then lastly, we had also natural regeneration, so where no catch crop was drilled, and we had two treatments for this. So firstly, we had natural regeneration after shallow disking on August 29th, so when the first catch crops were drilled. And this was approximately 10 days post-harvest of the spring barley. And secondly, then we had where no natural regeneration, where natural regeneration had taken place after no cultivations were carried out. So we can see here the natural regeneration that was dissed. We had a fresh weight yield of 4.2 tonnes a hectare, and we had 19 kilograms of nitrogen a hectare taken up. And that fresh weight yield basically came from the volunteers and weeds that were present in the stubble. And then secondly then, where there was natural regeneration, where no disking had taken place, we had a fresh weight yield of 2.8 tonnes a hectare and 19 kilograms of nitrogen a hectare taken up in this case. So this analysis is outside of the demo, but I just included this from another of our monitor farms. And this is just to show maybe a typical catch crop that's out on a lot of farms this year. So this mix is a leafy turnip and forage rape mix again, and it was drilled on the 20th of August, so about 9 days before the catch crop was drilled as part of our demo, and maybe more a typical sowing date of a lot of catch crops around the area this year. And just to know, no fertiliser was applied here. So from analysis of this catch crop that was carried out again on the first week of December, we see that there was 8.4 tonnes a hectare of fresh weight yield, and there was 40 kilograms of nitrogen a hectare taken up by this catch crop, which relates to about 32 units an acre. So this summary table then just brings together all the results, or certain results that I've picked out from the previous slides. And as you can see, I've ranked the different catch crop treatments in descending order of how much nitrogen they've taken up. So firstly then, we can see where organic manure was applied to the leafy turnip, sown on the 29th of August, we have 46 kilograms of nitrogen. We then have the leafy turnip and forage rape mix drilled on the 20th of August, and just to note that is from a different farm, but good just to show that that bit earlier sowing date was taking up 40 kilograms of nitrogen a hectare. So very close to the same species drilled on August 29th with organic manure applied. We then have the leafy turnip and forage rape drilled August 29th with no organic manure, and that has 25 kilograms nitrogen a hectare. Then we see the natural regeneration was coming in next, that was dissed on the August 29th, and it had 19 kilograms nitrogen a hectare. So very close in relation to how much nitrogen uptake from natural regeneration compared to, say, the catch crop drilled on August 29th. We then had natural regeneration with 11 kilograms nitrogen a hectare that wasn't dissed. And then lastly, the least amount of nitrogen taken up was by the leafy turnip and forage rape mix sown on that September 15 sowing date. So I suppose just in summary of all the results, we know that there was good catch crops generally established last autumn, but as you can see from the results, early drilling is still vital. There was good recovery of the applied nitrogen pre-drilling of the catch crops, so we nearly recovered all nitrogen that was applied based on our analysis of the organic manure. Cultivations early post-drilling were actually more beneficial for nutrient uptake or nitrogen uptake compared to a late drilling catch crop. And look, from the results, we know that most catch crops have potential to carry some nitrogen to the following crop, because most catch crops are looking good this year. But I suppose the question that I often get asked by malt and barley growers is how much nitrogen is actually available for the following crop. And the answer to that is it's extremely unpredictable. So the figure that we have on it in relation to recovery rate is anywhere from 0 to 40% recovery rate. So there are a number of factors that will really influence this nitrogen recovery rate. And firstly, we had talked maybe about crop termination. So when was the crop terminated? Was it maybe early in December, or was it within maybe a few weeks of drilling of the following crop? How much rainfall occurs in that period also? So will a lot of nitrogen maybe escape from the soil before the catch crop is drilled? Is the crop grazed? So if the catch crop is grazed, it will make that nitrogen more available to the following crop. And then also catch crop type. So if it's very leafy cover crop, it might retain more nitrogen versus a very stemmy crop, which mightn't make too much nitrogen available to the following crop. So I've just put an example in here of a standard cover crop. So this is the nitrogen content of that cover crop that I showed you in the previous slides. So for this example, I've put down that we have 40 kilograms of nitrogen a hectare in a sort of an average cover crop this year. And we'll say that will be a 20% nitrogen recovery rate. So maybe a cover crop that was maybe terminated, probably a month pre-drilling of the spring malt and barley crop that didn't receive much rainfall, that maybe wasn't graze. So that would maybe give us a 20% nitrogen recovery rate. So in this case, we can see that there's probably an 8 kilograms nitrogen a hectare available for the following barley crop. So we'll adjust our total nitrogen applied to our following spring malt and barley crop by about 8 kilograms nitrogen a hectare. But in reality, most cover crops won't be tested, so we won't know the exact quantity of nitrogen per hectare. So the best advice that I can give in relation to nitrogen available for the following crop is that if you have a good leafy catch crop, reduce nitrogen application in the range of 5 to 15 kilograms of nitrogen a hectare for the following spring malt and barley crop. And before deciding on the exact figure, maybe take into consideration some of the factors that I mentioned in relation to crop termination, rainfall, whether it was grazed, and the crop type, so whether stemmy or leafy catch crop.
Okay, Owen, thanks very much, Owen, and thanks very much, David. It's great to get an insight, David, from your farm, and certainly Owen from your from all that work that you did with those cover crops. It's good to do that. So look, we are going to come back to the lads in a few minutes to answer your questions, and there are a few coming in there already. And don't forget, if you want to ask a question, type it in on the Q&A session. It's just down there at the very bottom of your screen. But first, we're going to go to Dr. Richie Hackett, who's a researcher in Oak Park and very well known to all of you. And he's going to talk a little bit about the nitrogen input to malt and barley for 2022. So Richie, I'm going to hand over to you.
Okay, thanks for that, Michael. So I'm going to say a little bit about producing distilling barley, given that that's an ever-increasing market in the distilling, in the malting sector. So I suppose just a quick look at sort of what we're trying to do. So if we look at a very simplified view of a grain, of a barley grain, we have, and we take it as made up just of starch and protein. There's obviously a lot of other things in there, but just we're going to take it as just starch and protein. And we look at what we're trying to do. We're basically trying to maximize the amount of starch and minimize the amount of protein to minimize the percentage protein that's in the grain. And where does the starch come from? Well, that's coming from photosynthesis, which is the conversion of, or the use of light energy to convert carbon dioxide into sugars. And in order to capture as much light as possible, we need a good crop, basically. So we need a good canopy. And we achieve that by getting good crop establishment, good tillering, and good green leaf production. And we need to protect that green leaf as well. Where does the protein come from? Well, the protein essentially comes from nitrogen that the crop takes up over the season. And where are the sources of nitrogen? Fertilizer, manures, and soil. And I'm including in soil any material that has to pass through the soil, such as the cover crops that we heard about in Owen's previous presentation. So basically what we want to do, what we're always trying to do, is we're trying to maximize the photosynthesis, but using as little nitrogen as possible, or allowing as little nitrogen as possible to get into the crop, such that the protein is minimized. And that's sort of the key to distilling barley, if you like. So I suppose just to summarize that, we want to manage the crop for as high a yield as possible, but we want to avoid high nitrogen availability to the crop. We just basically want the crop running as lean as possible in terms of nitrogen. So how do we achieve high yield? Well, it's all the basics. We need to have our soil fertility right, lime, pK, trace elements. We need to have good weed and pest control and good disease control. I'm not going to go into any details in those, but they're all sort of the basics that you'll all be well aware of. In terms, I suppose, more specific management of malting barley, and in particular distilling barley, sowing date obviously has a large effect, and earlier sowing will tend to give higher yields and lower protein, which is obviously what we're trying to achieve. This is just some work that was done a good number of years ago now in Oak Park, where there are 3 different sowing dates: early March, early April, and late April. And you can see as you delayed the sowing, the yield decreased and the protein started to increase. Some more recent work done by Max Parton and Tommy Cabe in UCD again, where they had 2 sowing dates, so sort of an early sowing date, which was usually sometime in March, and a late sowing date, which was usually sometime in April. And again, you can see that as you delayed the sowing date, the yield went down and the protein went up. And the later sowing date had negative effects on a lot of other characteristics that occur in the malting operation after the grain has been harvested. But you need to be careful that you need to sow into good conditions. That's really key. So sowing early isn't the be all and end all. If you sow it in poor conditions early, you're going to suffer some problems. And again, this is just some work that was done a good few years ago now again as well. But two sowing dates, first sowing date in each pair. So the pale blue bar was where they went in and sowed the crop just as the ground was starting to come ripe, but it wasn't perfect. And the blue bar, the second bar in each pair, was where they waited a few days just for the ground to dry out fully, and where they sowed into good conditions. And where you waited those few days for the ground just to come right and be in good conditions, they got an increased yield and a decreased protein content in both years that they tried it. So it's not early sowing on its own, it isn't the key. It's early sowing in good conditions is the key. I suppose in terms, the big one is nitrogen, and that's the really difficult one, particularly fertilizer. How much fertilizer nitrogen should you apply to a crop? And I suppose the first thing to say is there's no one right rate of fertilizer. If we just look, so all these lines are how protein responded to increasing fertilizer rate in different trials over a number of years. I suppose the first thing you can see is that as you increased nitrogen, from about 50 kilos upwards, protein just stayed increasing. But if we just pick one rate, in this case, I just picked 150 kilos of nitrogen per hectare, and we look at the range of proteins that we get at one rate in different fields and different seasons, there's a huge range there. So there's no one right rate of fertilizer nitrogen to apply. When we looked at that data and looked at what was the percentage of crops meeting the distilling grade of 9.3% at each nitrogen rate, we can see that it's percentage meeting the grade increases as you reduce your nitrogen rate, but there's no rate that gave 100% distilling protein levels. So it's a question of balancing the risk of yield loss with achieving the distilling grade and achieving the premium for the distilling grade. And usually that balance is probably somewhere around 120, 110, 120, 130 kilos of nitrogen per hectare, but it will vary between fields. And the best guide is to look at your history, your own history of protein levels in your own fields, and to use that as a guide. I suppose one question that we're asked a lot this year is, obviously there's a very high nitrogen cost. Fertilizer nitrogen is very expensive. And the question is, should you reduce your nitrogen rate on distilling barley? Well, the short answer is no, not on distilling barley, particularly if you've been achieving distilling proteins in the past. Why are we saying not to reduce on distilling barley when we're saying that you should reduce on feed barley? Well, in distilling barley, obviously the protein spec is all important. If you don't meet the protein spec, you don't have distilling barley, you don't get the premium. But the main reason is distilling barley growers have already reduced their rates to achieve the protein, just to achieve the protein. So there's no further reduction advised. And if we just look at a very quick example where we've taken a 7.5 ton per hectare crop. If that was a feed crop, the normal N recommendation would be 155 kilos of nitrogen per hectare. We would be recommending that you reduce that by somewhere between 25 to 30 kilos of nitrogen per hectare, depending on your fertilizer cost, if it was feed barley in 2022. But obviously most growers that are growing distilling barley will be using less than that to start with. So we're saying no further reduction is required. So just in summary then, achieve distilling barley. First, choose a suitable field. So a field that has a history of low proteins is the ideal one, so long-term tillage. And in order to achieve low protein in that crop, maximize the crop yield as much as possible with using the minimum fertilizer input. And you do that by, choosing sowing into good conditions and getting your your phosphorus and potassium, right, and your lime, and good weed disease control. And in terms of fertilizer, nitrogen, you typically are not more than about 120 kilos of nitrogen will maximize your chance of low protein, but again, be guided by the history of your own field. It's a very quick run through there, Michael, so I'll hand back to you now.
That's brilliant. Thanks very much, Richie. It's great to get that insight. So I'll just ask Richie to turn on your camera, and David and Owen as well. So lads, we have a few questions that are after coming through the system, and quite a few of them, I suppose, are around the catch crops. So I might throw the first one maybe to yourself, Owen. And the first one is around, would drilling a catch crop of oats and mustard be better in that later drilling slot?
Yeah, we would have seen that out on farm, that definitely with the examples for mustard might have gone in, in that mid-September slot, or maybe just in the first week of September, and definitely performs better than going with the traditional glass mix. And we had an example of that that we tested this year, but I didn't get a chance to put it in the presentation. But there was no oats now involved, just mustard. But the mustard was drilled on the 10th of September, and it was taking up about 23 kilograms of nitrogen a hectare. So look, if we compare that to our leafy turnip and forward rape mix that we had on John's farm there, it was only taking up about 10. So definitely there's definitely potential, I think, in mustard for the later sown cover crop over the other types of crops available.
Okay. David, I wanted to throw you the next one here, and it's a question around have you seen a yield reduction in your distilling barley versus your brewing barley, because you're obviously putting on different nitrogen on the two sides of it?
Yeah, I mean, actually last year was the first year that our distilling barley outperformed the brewing barley. Now, generally, I would have found, we're growing Laureate and Planet, I would have found the Planet would have been about, say, half a ton a hectare above the Laureate. But last year it was actually the other way around. Now, I think it's more dependent on the season rather than anything else necessarily that we're doing. But that was the first time I'd seen it actually doing better than the Planet.
Okay. Richie, there's a second half to that question that was asked there, and maybe you might be able to put in some insight into it. And the question's around, could a GAI be developed around the catch crops, or I suppose, does that exist, or is it because there's certainly one out there for oilseed rape at the moment?
Yes, there's definitely one for oilseed rape, and in theory you could. I suppose one of the problems is where you have mixtures. So a GAI, you could probably develop it for the likes of if you only had forage rape or mustard or whatever, or oats. But when you have a mixture, it gets a bit more difficult. There are various systems that have been developed abroad to try and estimate A, how much nitrogen is in the crop, and B, how much is likely to become available. But they're all quite complicated, and exactly how well they work is a little bit unclear. But I think it's definitely something that needs more work in order to try and predict how much nitrogen will come from these over time.
Okay. Owen, I was going to go back to you. There's a couple of questions in there around the cover crops, the trial or the demo that you had in terms of the organic manures that were applied, and how much of that slurry was captured. I think the differential was only around 10 kilos, I think, in the fresh weight, was it? There didn't seem to be a lot. Or have you comment on that?
Yeah, so I reckon roughly we captured about 3/4 of the nitrogen that was applied in the organic manures, which we would have thought was a pretty good result, really, about how much that we actually got back out of it. So when we saw the differences in the field visually, there was a huge difference. But I suppose, as you've seen in the test, when we took the fresh weights of them, they weren't massive, but there was probably a good difference then in the amount of kilograms nitrogen per hectare that we've seen in the samples that we got tested.
Okay. Richie, I'll just throw you this one here, and it's a question really around the availability of nitrogen in the soil. So the question is really around trying to grow malt and barley in fresh ground. But I suppose we could have a similar kind of scenario with organic manures going on ground in terms of the availability of nitrogen. How do we cope with that?
It's not easy, because particularly the fresh ground bit is probably the most difficult, because you don't know exactly how much nitrogen is going to become available over the growing season, and that's the catch. You could go out today and measure the amount of nitrogen in the soil, but that's only half the story. It's how much is released over the period from the decaying grass material or organic matter. The organic manures are probably a little bit easier, particularly if you're putting them on worn ground, and that we have a reasonable idea of how much nitrogen is going to become available from the organic manures. So the likes of pig slurry, you'd expect about 50% of the nitrogen to become available of what's actually in the stuff that you apply. And the key is that you test what you apply and you know what exactly you're applying. So the organic manures are a little bit easier. I think the advice would be, for distilling barley in particular, I wouldn't be trying to grow it on fresh ground. It's you're stacking the odds against yourself from the start.
Yeah, not the place to go. David, just the very last one to you before we move on to the next session. And there's a couple of questions in there as regards grazing the catch crops off. And what sort of an allowance do you make around nitrogen? That you give it a little bit more or pretty much the same, or what do you do?
Yeah, so what we've done actually with all our cover crops this year, they're all being grazed by sheep. Now they're still out there at the minute. So like for me, I'm kind of hoping that we might get them ploughed more or less just straight before we're going to sow. That's obviously going to be dependent on the weather. But ideally, we'll leave the catch crop in there for as long as possible to try and stay absorbing nitrogen for as long as possible. You can actually see where the sheep had grazed, say in December, the catch crop is growing back up again. So, you know, it's still going, it's still hopefully taking in some nitrogen, but it's at a level now where we'll be able to plough it in. So in an ideal world, we'll plough them, leave them a couple of days, and then sow them maybe 3 or 4 days afterwards. And if I'm feeling brave, we could be looking at maybe taking out 33%, which would be 15 kilos of nitrogen based on the analysis that Owen did. So there's 45 kilos in the crop. Because they've been grazed, because we're not ploughing them until late, and we're hoping then that it's not going to get washed away, we could go maybe as high as 15, but that'll kind of depend on how brave I'm feeling on the day.
Okay. Thanks very much, David. Lads, we're going to come back to you again towards the end of the webinar, but we're going to move on. And thanks very much for all your answers. So we're going to move on to the next session, which is really around sustainability. So we're going to go to John Crowley, who's a farmer down in Wexford, and John has been working with us in the joint program for the last number of years in terms of opening up his farm and I suppose and how he practices on his farm. So Owen has done a small video with John down on his farm, so I'm going to hand it across to John.
So I'm here today on the farm of John Crowley, who farms just outside Ferns in County Wexford. And as many of you will know, John has been a participant as part of the Teagasc Boortmalt Joint Programme as a monitor farm for the past 3 years. So I'm just going to speak to John today a bit about sustainability on his farm and how he sees it fitting into his farming system, and especially in relation to malt and barley. So the first question I put to John is just to get a brief introduction into his farm and the crops that he grows.
Yeah, I'd be predominantly spring barley, spring malting barley with some winter barley and some spring beans. I'd probably be a little bit unusual as regards to the field size here is quite small. So I would have 12 kilometres of hedgerows on the whole farm itself. And then on top of that, there's about 12 acres of planted forestry and about 4 acres of native woodland. Mixed into that then, there's also about 9 acres of wildboard cover and low input permanent pasture.
The Carnot series soil type found across most of John's farm is extremely free draining, and as a result of this, catch crops have become a major part of John's farming system in order to try and help reduce nutrient runoff from his land. John will now discuss the importance of catch crops to his farm and what his plans are for the future in relation to catch crops.
Yeah, considering the majority of the farm was spring cropping, a lot of land would have been left bare here over the years. We were moving more towards cover cropping with the likes of the gloss scheme, but after Teagasc assessment, we've really kind of seen that we really need to move towards probably 100% cover cropping on that type of land, especially considering the type of land is being a leaky land and the fact that the farm is bounded on 2 sides by a stream as well.
As John has just outlined, cover crops are becoming more important on the farm for reducing nutrient runoff, and now John will examine some other areas that he would like to improve in order to enhance his environmental sustainability going forward.
Yeah, moving towards 100% cover cropping is definitely something we're looking into. Also the incorporation of organic fertilisers, and even moving towards putting those organic fertilisers on the cover crop rather than the main crop. We're looking at that at the moment, and the maximise the potential of hedgerows in the farm, which probably haven't been over the years. And I suppose lastly then the straw chopping scheme, which I participated in last year, which worked out very well for the environmental sustainability of the farm. And going forward, I think it'd be a great thing to to have that there and the financial backing of it to know that it's going to work out for the farmer as well as the environment.
Okay, John, thank you very much for that. It's great to get an insight into the practices on your farm. And again, thanks again for the participation in the program. So look, if you want to ask John a question, it's the same story. Just down below on your screen there, look at the Q&A tab there, type in your question, and we'll try our best to get to it. But before we get to those questions, we're first going to go across to Dr. Gary Lanigan from Teagasc, who was going to give us a bit of an insight into the sustainability of malt and barley and some of the factors that we can do to help reduce the greenhouse gases from malt and barley production. So Gary, across to you.
Today I'm going to be talking about the carbon balance of croplands and how we can make a malting barley system, for example, greenhouse gas neutral. So first things first, the carbon footprint of cereals and crops in general is actually very, very low compared to milk, which has a carbon footprint of 1 kilo of CO2 equivalents per kilo of milk, or meat, which is for beef is 16 to 20 kilos of CO2 equivalents per kilo of meat. The carbon footprint of cereals is substantially lower, somewhere between 300 to 500 grams per kilo of grain produced. And the actual source of the emissions are actually quite different. So whilst meat and milk, the majority of the emissions are from methane from enteric fermentation and from manure management. In cereal systems and cropland systems, the main emission is associated with food processing on the one hand, but also on farm, the main emissions occur from fertiliser, N2O emissions from fertiliser applied to the soil, and also then N2O emissions from nitrogen leached from the soil. So you have mainly N2O dominates cereal production, methane dominates livestock and milk production. And again, as you can see, the on-farm emissions are N2O, also then fuel usage, and also grain drying. And then you have the other substantial emissions are off-farm, so these are the production of mineral fertilizers, and also then the transport and processing of the product. So N2O emissions from soils for cropland soils tend to be very low compared to, say, grassland soils. And this is for a number of reasons, but mainly most of our tillage soils are on trafficable free draining soils. These soils are free draining, so they have low levels of what we call denitrification. So the nitrate in the soil doesn't get denitrified to N2O. The nitrate in the soil is either taken up by the plant or is leached to groundwater. So the rule of thumb is that grasslands tend to denitrify their nitrate to N2O. Croplands tend to leach their nitrogen and not denitrify it to nitrous oxide. Okay, if we look then at the other side of the coin, and one of the other big loss from cropland systems, which is generally again not seen in grassland systems, is the whole piece on carbon sequestration. And carbon sequestration and carbon sinks, we call them carbon sinks, because they are actually literally analogous to sinks. So, and the size of the sink depends on how much clay you have in your soil. So a sandy soil would be like a washhand basin. More silty soil would be like a much bigger sink. A clay soil like a bath, and a peat soil almost like a swimming pool in terms of the amount of carbon that it can hold. So if we look at the impact of soil type and land use, so the first thing that you can see is that croplands tend to have the lowest amount of carbon in the soil, and this is because the action of ploughing breaks up soil aggregates, and the carbon within those aggregates are then exposed to soil microbes and used for can be then used as an energy source, and that carbon is respired as CO2. But if you can also see that there's a big impact of soil type. So the brown earths tend to have the lowest carbon content, and the glazed and podsols have much higher carbon content and are much more responsive to land use change. The very free draining brown earths are much less responsive to land use change, which is why, again, putting tillage on brown earths is actually much more favorable from a greenhouse gas point of view, because you don't get a big land use effect. But what can you do to increase your soil carbon levels? So one thing to bear in mind is that increasing soil carbon and soil organic matter doesn't just help the climate, it improves your cation exchange capacity, which increases your nutrient availability, it increases your soil water holding capacity as well, and your overall soil fertility will improve as your soil organic matter improves. One of the things you can do, of course, is add manure onto the soil, and if you add on slurry or farmyard manure, you can see over the years, this is data from Rothamsted, you can get a large build-up, a big increase in soil organic carbon, okay? And depending on the rate at which you apply, and also the type of manures or slurries that you apply, you'll be adding more or less carbon, okay? So adding farmyard manure is much more beneficial than, say, adding on cattle slurry. Okay. One of the other measures that we have is incorporating straw. So again, an experiment here from Oak Park, where we looked at straw incorporation. What we see is that we get quite a substantial increase in straw in soil carbon, an 8% increase in our soil carbon content at an application rate of 4 tons of straw over a 20-year period. So the early warning sign that we see before soil carbon starts to change is an increase in soil microbes. So microbial activity and microbial biomass tends to increase first, and then we see soil carbon increasing later. And in fact, we use microbial biomass as an early warning sign that actually soil carbon is going to go in the right direction. Again, cover crops can also increase your soil carbon, mainly because it reduces the period where there's no green cover, and so prevents a lot of carbon loss out of that system. And in fact, we see that there's a linear relationship between the size of the fallow season and how much carbon is taken and remains in the soil. Minimum tillage is good for soil structure and soil health, and certainly there are benefits in terms of the number of earthworms and other soil invertebrates. However, in terms of soil organic carbon, what we've seen, again, this is from Oak Park data, is that while you get much higher levels of soil carbon in the top 10 centimeters in the min-till system, actually throughout the entire soil profile, there's very little difference between a minimum tilled soil and an inversion ploughed soil. Where you do see differences occurring tend to be on soils and in climates that are more water limited. So certainly in Southern Europe and in parts of the United States, large min-till trials have shown a benefit, and it's mainly related to the increased water holding capacity of that soil. And then other things that you can do on your farm to increase soil carbon and reduce emissions is to maintain your hedgerows. So if we look here at the hedgerow that you would think is well maintained, we would call that a very badly maintained hedgerow. In fact, if you allow your hedgerow to grow out a metre and grow up a couple of metres, you can sequester up from between 2 to 4 tons of CO2 per kilometre extra per year. Okay, and then other things you can do is introduce woodland features into your system. A broadleaf woodland will sequester about 19 tons of CO2 per hectare per year. Sitka spruce will sequester about 30 tons of carbon per hectare per year. But of course, the broadleafs are in place for about maybe 100, 120 years. Sitka spruce for maybe only about 40 years. So while the rates of sequestration are higher in the coniferous species, the total amount of carbon actually held in is greater in the broadleaves. Plus you get the diversity benefits in the broadleaf woodland as well. So if we look at a typical malting barley situation, so this is a 100-hectare farm, and it's got malting barley on it, spring barley, winter barley, and beans. And what we see is that the on-farm emissions, which are mainly fertilizer-based emissions, are about 25 for the entire farm. Grain drying and fuel operations adds somewhat to this, so you end up with a total on-farm emission of 452 tons. The NPK manufacture for the entire farm, these are the off farm upstream emissions, as we call them, adds nearly double those emissions. Okay, so in fact the emissions that occur off farm are nearly as important as the on farm emissions. So you end up with total emissions of about 800, just over 800 tons of CO2 for the farm. If you put in cover crops, straw incorporation, and alter a little bit maybe of the type of fertilizer that you have, you can reduce leaching and N2O, you can increase soil carbon from both cover crops and straw incorporation, and you can reduce those emissions by about a third to 670 tons. Okay, that's your total emissions there. The on-farm emissions, though, when you take away manufacturing emissions, are reduced to 254 tons. So about halved compared to your before you put the mitigation in place. And then if you put in a couple of hectares of conifers and a hectare of broadleaf, and then improve your hedgerow management, I'm assuming here about 12 kilometers of hedgerows on this farm, you can actually then become carbon neutral. So completely carbon neutral. So your initial emissions intensity of grain is 336 grams per kilo of grain. When you put in place all the on-farm measures minus the hedgerow and broadleaf, you bring it down to 106. And then when you bring in the hedgerow and also the broadleaf measures, you bring it down to 0, essentially. So again, these are the pathways that you can make your farm, your tillage farm, carbon neutral, and the product you're producing carbon neutral. So in summary, keep an eye on your fertilizer, keep an eye on your soil organic matter. Okay, soil organic matter is just as important for increasing soil quality and maintaining yield, particularly if you're going to reduce the amount of fertilizer. Minimum tillage increases carbon in topsoil with not denitric soil profile. Straw incorporation, rotations, cover crops, grass lays are all effective at improving the carbon balance of your system. However, one word of warning is that you have to keep on doing these measures because sequestration is actually reversible. And then ultimately, woodland and hedgerow management can help achieve a carbon neutral farm for very little hectarage. In fact, they don't necessarily need to be blocks. You could have, for example, riparian strips of woodlands intercepting water down to, say, a waterway or whatever. Or you could have, again, you can have woodland features. They don't necessarily have to be full blocks of woodland. Okay, thank you very much.
That's great, Gary. Thanks very much. Thanks for that presentation, and to John as well for the video. Guys, we have a few questions that have come in, and Gary, I might just go to you first. In the calculations that you were doing, which reflects John's farm and what John is doing on his farm, you talked about 2 different big lumps of greenhouse gas bits. You might just maybe go back over that in terms of what's Irish, if you like, and what's the carbon footprint bit.
Yeah. So really the big emission on farm from the tillage operation side of thing is the application of nitrogen fertilizer. That really dominates everything. And that accounts for on farm probably about 80% of emissions. Okay. The off farm component again is just as big, and that's the fertilizer manufacture, right? So if you want to reduce your carbon footprint, be careful which company you buy your fertilizer from. If you want to reduce your on-farm emissions, the first thing, if you're a tillage farm, is get rid of any cattle you have, and then after that, the main things are to employ cover crops, strong corporation. You could move to a no-till system if possible, and then to manage your hedgerows in a way that we probably think is not good hedgerow management, i.e. to allow them to grow out and up, okay? And you'll essentially quadruple the amount of carbon held within those hedgerows. And then after that, as I said before, incorporate woodland features where possible. And as I said, it doesn't have to be blocks of woodland. It can be buffer strips. It can be feature. It can be small features, simply to get a few hectares of forestry in.
So Gary, just so I'm clear, because we can often get very confused in all these different figures that are going around in terms of what Ireland has to account for, and which might be different to what the world has to account for in terms of what's making a difference. Am I right in saying that the manufacture, because it doesn't happen in Ireland, is accounted for by somebody else, by the UK who does it, by Russia,
correct,
who does it, somebody else who does it? So
correct.
From an Irish accounting point of view, we only have to account for the bit that might be lost through going up in the air through nitrous oxide or through leaching down below. That's the bit.
Yeah.
However, it mightn't be as simple as that. Am I right in saying, because if I'm selling whiskey or beer, the consumer might want to know the totality of it, not necessarily the bit that's going to be accounted. So it's a bit complicated. Yeah.
So these are the two different things. So the carbon footprint includes the totality of emissions. Okay. But our national emissions are essentially just what we produce within the state. So from our on-farm or national emissions, croplands are actually very, very good from a carbon balance point of view. Far lower. Orders of magnitude below beef production and about 2/3 below milk production.
Okay. Okay, thanks very much, Gary. John, I want to come across to you. There's a couple of questions here for you. One is around, John, what is the normal catch crops that you put in, or are you going to put in? And also a question there around, why are you applying organic manures to those catch crops rather than to the main crop, the barley itself?
Yeah, I've been using the standard, I suppose, gloss mix, the leafy turnip and forage rape. If I go down more the min-till route, I might use more tillage radish. But for the moment, I find the standard gloss mix working grand. As regards putting on organic manures post-harvest, I find it's easier trying to get in with spring barley. It's this time of year, we've had quite a dry time this year, but oftentimes it's very wet. You can get in after harvest, dry land, less compaction. It's a quieter time of year generally as well, and you get your cover crop in easily. You can also see how well that cover crop goes then coming into the spring, see how it's performed over winter, and gives you a better idea how it's going to work into the following crop. The question is how much of the organic manures has been leached out over the winter, and I think Owen is doing some work on that there at the moment as well to see, is there going to be a complication coming from that, and do we need to look at that again?
Because I suppose in the background we're in trouble, I suppose, in the southeast in terms of nitrates getting into rivers, and you have to try and mop up as much of that free nitrogen as you can. So yeah, thanks for that. Gary, I want to go back to you for a second there, just in terms of the do you have any details as regards direct drilling and its effect on carbon in the soil?
We don't at the moment. We're starting a study on that now this year. So we're putting our CO2 flux towers over direct drilled fields. So come back to me in 12 months, Michael, and I'll give you the answer to that.
Perfect. I think that's it's ideal. More research needed. As a typical researcher, more research needed. I like that.
Yeah.
Okay, John, just back to you for a quick question. You have incorporated some of your straw this year, or last year, I should say. Are you going to make an adjustment now in your P's and K's, or have you the ability to do that this year?
I'd love to, considering the price of fertilizer this year, but I probably won't. For this year, I'll watch the soil samples going forward, just to see how it's affecting the soil with the type of soil I have. If it's building, then I will definitely be cutting back, but it'll be more of an ongoing process of watching how it's going.
Okay, great stuff. Guys, look, we're kind of out of time. We need to move on, and thanks very much. We might get you back in a few minutes again. We just have the last section to run through, so we'll get you back again in a few minutes. Okay, so for the last section, we have kind of two bits to it. We're going to go first to Owen Lyons, who's going to just give you a little bit, a quick update around the joint program and some of the work that he's been going on that. And again, look, keep your questions coming. There's a good few questions there. We'll try and answer some of them to you directly, and we'll try to come back and answer as many as we can live. And look, we are going to run a little bit over. We're probably going to run to about 1:45. So, okay, across to Owen.
So for this presentation, I'm just going to give a quick update in relation to the Teagasc Boortmalt Joint Programme and some of the activities that have taken place over the past year or so. So to start, I'm just going to look at the soil sampling and look at the incentivised soil sampling campaign that we have carried out over the first 3 years of the joint programme. So many growers will be aware of the soil sampling campaign or would have participated in it, and as a result of this, we have just over 2,500 soil samples that have been analysed. And these samples have come from specific malt and barley land across the southeast, which now means that we have specific information in relation to the soil nutrient status of the malt and barley soils across the southeast, and we can now use this information to best inform growers on to form nutrient management plans in order to maximise the potential of malt and barley soils. So the graph here just shows the results in relation to the samples that we've taken as part of the incentivised soil sampling campaign. So what we're seeing here is the percentage of pH, P and K that is at optimum across the 5 main counties where the samples were taken. So firstly, we'll just look at the red bars, and this is optimum pH percentage. So optimum pH percentage in this case is the quantity of soil samples analysed that had a pH of 6.5 or greater. So firstly, we'll just look at Wexford, and we can see here that 52% of the soils analysed were at optimum pH. For Carlow, that figure is 73%, Kildare 93%, Laois 87%, and Kilkenny 75%. Secondly, we'll look at the light green bars, and this is optimum P percentage. So optimum P percentage in this case is the quantity of samples analysed with an index 3 or 4. So for Wexford, only 1/3 of samples are optimum for P. For Carlow, that figure is 89%, Kildare 82%, Laois 84%, and Kilkenny 71%. And finally then, we'll look at the optimum K. So the optimum K here in this case is similar to the P, so it's quantity of samples that were either index 3 or index 4. So for Wexford, we see that figure is 78%, Carlow 71%, Kildare 49%, Laois 63%, and Kilkenny 62%. So just to look at some of the outcomes or observations from these results that have come back in. So what we've seen is from the results that there's major differences in relation to soil nutrient challenges for growers depending on location. So each area will throw up different challenges that growers must meet. So what I've done here is I've just separated out Wexford from the other counties. And the reason for this is that the soil nutrient challenges in Wexford are a lot different to the other counties that have been listed. And the other counties here have much kind of similar challenges in relation to both P, pH and K. So what we've seen in Wexford that there's generally low P and pH but a high K. And then the other counties, then we see that high P and high pH. And although K is still below what we've seen in Wexford, it is still above average. So our normal advice here in relation to our nutrients will be to match crop offtake if we're in index 3, and if we have an index 1 or 2 soil for our P or K, we would be recommending to apply a build-up to them lower index sites. However, as I said, that's typically what our message would be, is to apply them build-up applications to index 1 and 2 soils. But given the current year and the current fertiliser prices, it is extremely difficult to try and apply them build-up applications and grow a profitable crop. However, it is still vital that we match applied nutrients to crop offtake, because if we don't apply the crop offtake, the crop won't meet its full potential. So with keeping this in mind in relation to matching crop offtakes for the crop, this table here just shows firstly the soil P and K index, and then depending on the soil P and K index, the application of P that should be applied and the application of K that should be applied. And just to point out that these figures that we see here in the table are based on the target spring malt and barley yield of 7.5 tonnes a hectare or 3 tonnes an acre. So as I said, typically if we had a soil in index 1, we apply crop offtake plus build-up, which would come to 49 kilograms a hectare of P and 15 kilograms a hectare of K. If we had an index 2 soil then, we would apply 39 kilograms a hectare of P and 100 kilograms a hectare of K. However, this year we were just going to target that crop offtake. So crop offtake in this case will be assuming an index 3, a soil of index 3. So in this case, if we have an index 3 or crop offtake, we'd apply 29 kilograms a hectare of P or 23 units an acre, and 85 kilograms a hectare of K or 68 units an acre. And that then will match our crop offtake, assuming that we have a yield of spring malted barley of 7.5 tonnes a hectare or 3 tonnes an acre. And we'll see then there in the table that if we have an index 4, there is no allowance for either P or K for this soil. However, as many growers in the Midlands around Kildare, Laois and some of Carlow will know that these very high pH soils have a very high index 4 for P, but an awful lot of that P is locked up because of the high pH soil. So there isn't, just to remember, there is an allocation here to apply 20 kilograms a hectare of P to these soils, which equates to about 16 units an acre. Moving on then, and just to focus briefly on seeding rates and getting our seeding rate correct. So we all know that if we have our seeding rate correct, we will produce a high yielding crop. So this diagram then just illustrates that. So if we sow 350 seeds per metre squared, we just get a predicted establishment rate of 85%. This will mean that we achieve our target of 300 plants per metre squared. And by having this good establishment of 300 plants per metre squared, it'll mean that we get good tillering and produce a high shoot number, and high shoot number is vital in order to produce a high yielding crop of spring barley. So the table then here just shows the malt and barley varieties that are available through Boortmalt for this season, and also the average 1,000 grain weight for the varieties. So for Planet, we see here that the 1,000 grain weight is coming in at 52, Laureate the same, also at 52, and Tungsten at 1,000 grain weight of 53. But just to remember that the figures above, they are guidelines, and each seed lot may vary, so it's very important to inspect each seed lot before deciding on your seeding rate for the crop. So the seed rate formula here just shows how much seed that should be sown. So you can see here the formula goes with a target plant population per metre squared multiplied by our 1,000 grain weight of our seed lot, and divide that then by a percentage establishment, and that will give our rate. So to follow that example through then, our target plant population here is 300 plants per metre squared by our 1,000 grain weight of 52, which is the average 1,000 grain weight of Planet, and divide that by our percentage establishment rate that we'd like to achieve, which is 85%. So that gives a seeding rate of 183 kilograms per hectare. So finally then, just to look at our crop demos for this year. So will be continuation of crop demos on the monitor farms as we have done for the past 3 years. So what growers can see then as part of our crop demos over the coming year, so we'll be looking at seedbed preparation, which is very important in certain areas of the catchment, and making sure that we have adequate pressing of the soil. We'll be looking at establishment systems, so we'll be looking at the systems of no-till, min-till, and a plough-based system, and try and look at the performance of the crop based on establishment system. We'll also have seeding rate, and linking into these alternative seeding rate, we'll be looking at plant growth regulators and the performance of plant growth regulators depending for producing more tillers based on seeding rates. And we'll also be looking at new malt and barley varieties that are coming through the system and how they perform on the monitor farms. So the Boortmalt Joint Programme is set to run for a further 3 years. And although we've missed the past 2 years in relation to our monitor farm crop walks, they will return for this year. And there'll be a range of them over the growing season, and that growers can come in and see in each of the different monitor farms. So what growers can expect then from these crop walks is to keep a bit up to date with crop agronomy of spring malt and barley, and we'll also have an extensive viewing of our crop demos that I've just outlined.
That's brilliant, Owen. Thanks very much for all of that. And it's clear to see there's a huge amount of work going on in the joint program. And look, we are working with terrific farmers and their willingness to accommodate some of those trials and to allow other farmers to come in to have a look at those trials, I think it's fantastic. And it's hopefully we'll have more and more of them going on this year. So for the very last small bit of a video, we're going to go across to Tom Bryan from Boortmalt. He's going to chat about the new malting plant that was built over there and say a few words about that. So Tom, across to you.
My name is Tom Bryan. I'm 33 years working with the company. I'm the Regional Agronomy Manager for the UK and Ireland. Malt is so important for Ireland basically because there are some very significant global brewers and distillers based on this island. That market requires malt, and the alternative to not producing it here on the island is importation, and importation is not sustainable.
My name is Noel Gaffney. I'm the Plant Performance Manager for Boortmalt Joint, also project manager from numerous projects around Europe. Buehler and Boortmalt sat down for months on the design, the specifications, and they delivered exactly what we asked for.
The reason why we built the plant here in Athy is that we had a significant business footprint here right from the start. Back in 1847, the Minch family founded the business of malting on this site, and now to fulfill the demands of the market, we've added the Buehler plant, and it meant that we have utilised all the existing facilities on site while adding a new plant to it. Really sustainable way of producing. The significance for Boortmalt in this particular region is that the surrounding counties, the counties of Kildare, Laois, Carlow, Kilkenny, Wexford in the main, produce a large volume of malting barley. If you have the facility based within the area in which your raw materials are produced, you're drawing the production from the local area, you're facilitating local people, and then you're supplying the product on to our final customers. So it is a huge supply chain of which the plant is integral.
It's very efficient. The accuracy and the reliability of the equipment on site is second to none. Buehler Inside Replay collects the data from a control panel, from devices, machinery. Data is sent back to Buehler Insight, and from there we create dashboards, trends to monitor what's happening on a batch by batch basis. You can make instant decisions in real time, from process optimization to faster process diagnostics to RCFAs. It's a game changer for the maltons.
Boortmalt are committed to sustainability. It is one of the key pillars in our organisation, and that's the reason we're proud to be involved with Teagasc in developing the joint programme on malting barley production, which is to help all farmers in Ireland to produce their cereals in a more sustainable and profitable manner.
We have a group target on reducing our emissions by 42% by 2031 For us to achieve that target, we need innovative technology to assist us. We will have to work with multiple partners, and Bühler are one of them. We chose Bühler because they're experts in their field and they're not going anywhere.
It's a phenomenal plant. I have never seen anything as clean, as silent. It is a brilliant piece of engineering, and all you have to do is look behind me and see the quality of the building. It's really super. We're so proud to have it here in Ireland.
Brilliant, Tom. Thanks very much for that, and thanks for producing that video. I might ask Tom and Owen just to turn on your cameras there for a minute. Tom, there's a few questions kind of coming through there. I might ask you one first, and you mentioned sustainability there as you went through that video. How much of that is coming through the supply chain? How much influence has been exerted to you or onto your business to make sure you're as sustainable as possible all the way through what you do, coming back and with stuff you supply?
Yeah, Michael, yeah, that's an interesting question. Yeah, it's integral to all business now. There's targets out there globally, which every brewer and distiller, malt producer, etc., has to reach. So it's an integral part of the supply chain and something that will be here for the future. Okay, great. Owen, I just wanted to come to you and just ask you just a quick question there, just in terms of your soil samples. How up to date are people in the soil samples? Are most people kind of thereabouts? They're within kind of 3 or 4 years of having a fresh soil sample?
Yeah, I would say it's much up to date as could be, really. And over the first 3 years of the joint program, I suppose we would have got the majority of Boortmalt suppliers in under the scheme and got samples taken. And no, the offer is there again, and people have a full allowance again to go take samples again. So I'd encourage everyone to, if they don't have samples up to date, to get them up to date over the next few years as the joint program continues.
Okay, and complete a nutrient management plan, I suppose, in the back of it too, I suppose.
Absolutely, yeah.
Okay, Tom. Obviously, there's been quite a few changes within your business in terms of how you bring your barley into Boortmalt. What sort of changes are there for this year in terms of agronomy services, in terms of supply of inputs, that kind of thing?
Okay, yeah, good question. Yeah, there's no real changes this year. So 2022 will be a continuation of 2021. So the areas of Wexford, Cork, Laois will be covered by the crews that are there at the moment. We don't envisage any change. As well as that, an interesting thing, and it came from the Teagasc Joint Programme, the research work that Owen had performed. In Harvest 21, we operated a system where we increased the distilling cutoff point to 9.7, whilst maintaining the 8.8 to 10.8 brewing parameters, and that will continue this year as well. The facts are that in 2021 we only had a 2.7% rejection rate. Mainly, obviously, it was a great year for growing crops, but mainly because we had the flexibility that overlap in proteins allowed. So again, something that we will continue with, and it was thanks to the program for pointing that out.
Okay, and is there any other changes in terms of malt and barley specs that are here? Somebody mentioned KPH might be changing or not?
Well, it won't be changing. KPH was there last year, and we're going to continue with it again this year. The main change in relation to KPH is that we will be paying a bonus deduction system on it. So encourage higher KPH levels. Okay,
to what base, Tom?
63. So baseline is 63.
Okay, that was the same as last year, was it?
Yeah, it should have been the same, yeah.
Okay, great. Okay, I might just invite all of the other speakers maybe just back in here to join us again just for the last few minutes, because we're maybe just a little bit over time. We might only get to a few more small questions. I just want to throw one to David, and again, it's kind of back to this sustainability bit. And congratulations on your Ballykilcavan brewery. You're going from strength to strength, I think. And I know you're in the middle of kind of building a brand and building that end of it, but is there anything that you can see coming from your consumers that you're directly attached to in terms of that sustainability bit? Are they demanding anything on your bottle to kind of say that it is or it isn't as sustainable as something else?
Yeah, I mean, from the business point of view, from the brewery point of view, it's actually hugely important now. Just from a business point of view, I mean, I suppose we'd always like to think that we had that ethos anyway, but it is very much we're, in terms of what's really important for us actually is say on export. If we're going talking to distributors in France or Italy or somewhere like that, that's one of the first questions they will ask us is what sustainability, what environmental credentials do you have, and how can you prove it? So you can't just say, we're doing nice stuff. You have to actually be able to come up with numbers for it. So for us, the vehicle for that is the Board Bia Origin Green. So that means it's an independently audited. Now I know that it'll come in for criticism from certain quarters in terms of some of the big companies that are in it. It's actually a very good framework for us. It's very good discipline for us because it's independently set targets that we have to adhere to. And that then means that we can access a lot of the Board Bia stuff as well. So for the company the scale we're at, we have to be doing all these things. And it also means partnering with the likes of obviously Mincher producing our malt for us. We have to be able to partner with them to be able to, show that all our inputs are coming in sustainably and that we're processing them sustainably as well.
Okay, yeah, that makes sense. I mean, it's certainly it's in everybody's mind nowadays, I suppose. Tom, I just wanted to come back to you, and it's I suppose a relatively simple question in terms of new malting barley varieties coming into the system this year. Have you got one or two varieties there that you're testing or that is close to replacing the existing stalwarts there?
Yes, yeah, we're constantly testing every year, as you know. But in looking from the 21 crops, it looks like there is a variety. LG Mermaid, it looks like one that has a real promise. It's about 8-9% ahead of Planet, just to put it in relative terms. And there's three other varieties as well, Florence, Gretchen, and Spinner, that we're looking at. They were on the recommended list. All have great potential. So they'll be going into pilot batch production this year, so maybe a couple of 100 tons, to see how they perform in the malting plant. Is there any issues with it or not? And do they distill correctly? Yeah. So it looks like a step change is about to happen in 23.
Brilliant. Excellent. Richie, just wanted to throw a question to you. Question there around the placing of nitrogen or all of the nitrogen into the seedbed and how that might affect protein towards the end of the season.
Well, we looked at that a few years ago, where we either put a lot of in the seedbed, or we held back some until mid-tillering, and we could find no difference on either yield or protein, as long as you have some in the seedbed. As long as you had it all on by mid-tillering, there was little difference in how you divided up your nitrogen.
Okay. John, I'm going to come to you for the next one. There's a question there around hedgerows. Gary mentioned hedgerows in terms of managing those hedgerows. You mentioned on the other side of it that your fields are relatively small with plenty of hedgerows out there. And Gary mentioned let them go wide and let them go big. Is that something that you were considering doing, considering your field size?
It's something I'm definitely looking into. Obviously, with my average field size is just under 6 acres. So I'd be a little bit concerned about shading in fields and that kind of thing. But definitely there's parts of the farm that there's massive improvement needing to be made. And anywhere I can do it, I'll definitely be doing it. With 12 kilometers of hedgerow on what is 180 acres of tillage here, it's quite a lot. But if it'll help to improve things going forward, yeah, definitely.
Okay, I'm just going to ask two more questions because we're a little bit over time. There's loads of good information coming here. Richie, just want to throw one back at you. There was a lot of oat and straw chopped last year. Malt and barley going back into that. How much of an effect is that going to have on maybe nitrogen for a start? And obviously there's P's and K's in there as well. You might have a comment on P's and K's as well.
Well, we're assuming that the oat and straw was incorporated last autumn. So in terms of nitrogen and phosphorus, there should be relatively little effect. There will have been nitrogen, a low amount of nitrogen going back into the crop, but it's slowly available, and very little effect on the phosphorus. The potash, the potassium is the big one, and you maybe expect to be reducing your K inputs by something 50-60 kilos of K per hectare. So in Owen's presentation, he mentioned in index 3, you'd be applying 85 kilos of K per hectare. So you'd be reducing that by 50 to 60 kilos of K per hectare.
Okay, Tom, I'm going to give you the last word because we are bang out of time. There's a question there, Tom, around kind of prices, as it kind of always comes up, so I'm going to throw it at you. There's just around the FOB creel price. Can that be made available to farmers? It can't be seen or accessed at the moment.
Yeah, that's an interesting one. Yeah, so we're working on that at present. Normally from the second week of April onwards, it's released on a weekly basis. So I'd see that continuing.
Okay.
And I suppose in relation to the specs, I've seen that the specs are as normal, no glyphosate, and as I mentioned already, 8.8 to 10.8 protein on the brewing, less than 9.7 on the distilling, and the usual normal screenings, KPH level, etc. that we would have. Nothing out of the ordinary.
No big changes. Okay.
No big changes. No.
Okay, great, Tom. Thanks very much for that. And look, we will have to leave it there. We are a little bit over time. We got through a good few questions. We typed some answers in. We answered most of them live. There's a few we just didn't get around to. But look, thanks very much, everyone, for putting in the questions. It was great. So look, I wanted to thank the entire panel for their contribution. David, Owen, Richie, John, Gary, and Tom for your presentations and also for answering your questions. And also in the background, Dara Whelan of Last Cast Media, who's helping us pull it all together, and Shay Phelan answering a few questions in the background. So thanks everybody for that. This webinar is being recorded and will be up on the Teagasc YouTube page very shortly for anyone who wants to go back over and look at it again. Okay, so from next week then, from February the 15th, next Tuesday, we're going to revert back to face-to-face meetings with a series of winter crop walks, which we hope will give you guidance in terms of the agronomy first agronomy actions for 2022. So the first of these actions are going to be held, or walks are going to be held in Oak Park, and you can see it there in front of you. And we're then going to move on from Oak Park down to Ballydrown in Cork. And then we have a walk in Brownstown in Navan, and in Crossabeg and Wexford, both on the Thursday, and on the Friday then the 18th, we have walks down in Kildalton and also in the ward in Dublin. So look, try your best to get to it. It's probably going to be one of the first outings. You can get a chance to hear hopefully a little bit of information you can take home with you, but also chat to your neighbours and other colleagues in the industry as well. So looking forward to seeing everybody there. So look, very lastly, don't forget we have the Tillage Edge podcast, which goes out every week. So don't forget to tune into that. It'll give you short updates as regards agronomy and things of interest from around the industry. You can find this on the Teagasc website page, Spotify, or even on iTunes. So look, that's it. Finally, thanks very much to everyone who turned in. Thanks to you. We're delighted that so many people could join us today. So thanks very much for that. Look, hopefully we'll see you again, but more so face to face this time. So look, stay safe and God bless.